Well, then maybe, somebody did.
Did Nichols she
Yeah.
say that it's
Yeah.
like the higher, like the gap between the lower or God bless you.
Thank you.
Basically, the better shimming you have, the better resolution you have, right? So
So
it's
you-
about clarity.
So you
on
want
being able to
shimmy.
See what the shape pattern looks like.
Right, for, to see the splitting,
Yes.
yes.
So without that, if it's not good, basically, this line is what shimming tells you, and usually it's supposed to be here. And because it's down here, it's just not going to be able to give you the option.
Okay, I thought, so shimming isn't dependent on the machine.
It is, because it's the machine that will shim.
Okay, so how did this same machine give us something that was this precise where you can see the bars? That's why I'm confused.
It's like the level of solvent, how soluble your compound is in that solvent. And things
So I
like
have to do
that.
with the
Okay, so
actual-
it does mess with what we put in it?
Yes.
Yeah.
Okay. When you said it was the machine, I was thinking like, that machine's always gonna be that unclear. That's what I,
No.
okay, that makes sense. Gotcha.
So does this make sense?
Yeah.
And who has the TMS, the tetramethyl
What
cycline?
do you mean, who has?
Like, is it already in?
Yes.
Is it in the actual machine?
Yes.
Or, okay. Yeah, put all my stuff in there.
So why is it upside down? Why are your peaks
Because
upside down?
now it's at the higher energy and you're about to watch it come down. Hey, Cripper.
It's one of those trick questions. It's just,
It's just the way.
It hasn't fallen down yet?
it gives you that way, and then you have to auto-phase it and flip it for you.
Okay.
Don't expect you to do it. I just like to mess with you.
Like, watch me strike it.
Okay, so this is a little bit more of a better spectrum. So what should I integrate that peak to?
The one next to the most electron. Like
So this one, how many hydrogens are there in that region? Which hydrogen is that in my molecule?
the one next to the OH. I mean
There's
the.
no OH.
I thought it's
But
two
the,
pentanol.
Yeah, but you've converted the 2-pentanol to an alkyl halide.
Oh,
So that
so
OH
the
is
bromine.
Bromine or
BR.
whatever.
Yeah, so,
Okay, so next to BR.
so
Right.
the same carbon that has Br.
Yeah.
So the
That
first-
same carbon is attached to two others,
Yeah.
and for only one hydrogen, right?
Mhm.
So that's why it's integrated to one.
So that one only has one.
Yeah.
That's the one that's next to the most electronegative
So what's the
Yeah.
thing beside? what's
because of the dipole
that-
moments.
You tell me.
beside it? Is that the BR?
Would you see Br in a proton
No.
spectrum?
Just hydrogen.
Well, is there a hydrogen right next to the neighboring carbon?
Okay, think about it. 2-pentanol, you have two products,
Right.
right? So they should be,
Oh, it's the second product's
Right,
hydrogen that's
because there
correct.
is nothing else in that same molecule that will come in around 4. They're all CH, they're the alpha region, right? So this has to be from the other molecule. So based on this, which one, like, can you predict the percentages of each?
It's gonna be more on the one upfield, I think, because wouldn't the upfield
The
one be more
rearranged.
stable?
This one is from, if you have the pentanol here, it's in the middle. Right?
Yes.
And that's integration is 1. The other one with the bromine is, well, not, I'm sorry I'm drawing on this, but, so what's the integration for that relative to this?
Here, you want a pencil? So we can visualize.
Yeah, on the back of that.
So we have bromine here, the other one, we have bromine here, and this one came from the rearrangement, because pentanol has really changed position, right? So this one being a little bit more stable than this one will come in a little bit more down here.
Because it's more stable.
The most stable
You have
one.
conjugation coming in from this side and this side,
Oh, okay.
right? Right? So what my question is, can you qualitatively tell me how much of each you have in your sample?
No.
Maybe.
Well, in an MNRI, you should.
Furthest downfield is like double the height. Isn't
Right,
it?
so instead of heights, we're looking at integrations, right? The areas, just like you did in your GC. Yeah, so that's 1 to 0.5.
Can you?
So it's half,
use
so
the
it doubled,
Area
yeah.
of the peak?
The integration is the area of the peak.
Okay.
So it doubled in height, so is that what you're asking? So 100% to 50%?
Width times half height, then that way.
It's not gonna be
Is
that
that-
No, that's what-
Okay, but you said it was like GC.
It was like GC, yes, so I'm just saying, use that same analogy where you can
Okay,
compare the two
okay.
integrations and tell me that there's 50%.
This will be 1, and then that would be, divide that by 1, so it'll be 0.5.
So it'd be like
That's what you said,
75%,
right?
25%.
There you go.
Yeah. 'Cause, I
Say
mean,
that
You
again?
said,
You'd get 75% and 25%.
Oh.
Because
Out
since
of
one of them
100,
is a
yeah,
half
yeah.
the size of the other one, that's how that one come out to be.
So
I don't know
75.
how to get that. I don't know how I came up with it. It just happened. My mind, I like math. Math and me, we get along. Me and chemistry, we don't get along.
Why are you in chemistry?
you
It's
need
'cause
it.
we chemistry don't
Gotta
make me
have
like
it to
it.
get into med school, man. So,
I don't wanna hear it.
You good.
no, I'm actually a psychologist.
Won't use chemistry again.
So what's that red line?
I wanna be a
Does that mean
psychiatrist.
anything?
No, but I'm saying you won't, yeah, you won't
That's
use it
taking
again.
area.
Ah, okay, okay.
The only thing
That's
I
like a
can
mathematical-
Yeah.
is,
Yeah.
I was just wondering what that was.
calcium.
I mean, obviously it means something because you're doing it, I just didn't
That's the only
know.
things I need to
Yeah.
know. And their concentrations inside neural cells and how the lowering of this concentration.
Do we have to worry
increases
about like the
with
tiny
happiness
pizza
and
up here?
blah, blah, blah.
Yes.
You right?
Like which ones?
Like here.
Oh, no. That's,
Okay.
That's noise?
What are we looking at?
Is that considered noise?
this, yes, but
Yes.
this, you should know what that is, because that's one of my questions, I want your answer.
Oh, that's number 7. That's what she told us Tuesday when we were going over there. What is 7 ppm located on the thing? I can't remember, but I remember. Dr. Nichols, when she had the lecture on NMR, she said 7 pp's, and then she had 9 to 10.
Yeah, the ranges.
Yeah, but what is 7? There was something she said about what 7 was.
So one thing you should be watching out for is this one, how many equivalent hydrogens are there?
How many what?
Equivalent.
hydrogens?
With this carbon hydrogen?
No,
There's
just
none.
like for this molecule.
Two.
Oh, there's two.
Two, and then
Two,
those two.
Right, yes.
Integration of these will be,
The same.
Three.
Oh, you want to know?
So it'll be 1, 2, 3,
Six.
3.
Yeah.
It's
Six.
six,
Six.
six,
Six.
three, and
Six,
three.
sorry.
because
And
it's
then
a
Six.
integrations for the other two would be 4.
So this one will be 3, and this one will be 3.
3. Yes.
Okay.
So when you're looking over here, make sure that you're doing it per molecule. So it's giving you 3, but this 3 is coming from this molecule, so you have to divide that by 1. And if you do, like, okay, what I'm trying to say is for your GCs and the NMR that I showed you in the lecture last time, remember how you have to divide the integration by itself to give you 1,
Mm-hmm.
because it's 2 different molecules, right? This one of them is automatically scaled. The other one has an integration of 0.5, so you have to scale the other integrations of this to match your molecule, right? So you know that this region will be around like about 1, right? And so will this one. One of these integrations have to be 6, the other one will be a triplet and a triplet, right? So here it's saying 3 for that one, and you know it's supposed to be 6, right? And there should be only 1 hydrogen here, and that's supposed to be 1. Here it's 0.5, so it matches. So when you're giving the integrations,
Oh.
just think about that.
Okay.
Got it?
Yeah.
So 1 to 6.
It's a little bit confusing, but
Yeah.
I had to follow you. Okay.
You got it?
So how do I know what?
No, I don't have it,
what comes
Sonia.
in at 0?
Oh, it does.
TMS.
Yeah.
Yeah.
Okay.
What did you? Okay, one more time about that, Sonia. I wasn't getting it.
Okay.
I know how to do the math part, but what you're
In this region, you should expect multiple peaks, right?
Right.
And you won't be able to assign all of them, but you should see an integration for 6 for these hydrogens. And you should see integration of a 3 here and a 3 here, right? Here, it's just giving you integrations of what it thinks relative to this hydrogen. Sorry, this hydrogen, right?
wrote to the hydrogen that the bromine is attached to.
Right, so if you
Okay.
want to scale it, then you would have to see, this is 0.5 to 3, therefore it's 1 to 6.
Right,
Like, don't
because
just
we know
assume, yeah.
that we have 6, but the machine doesn't.
Right,
So you
Okay.
have to convert what the machine gives you
Yes.
to 6.
per
because-
molecule.
Yeah,
You should have said, when I said 1 to 6, you should have said, yeah.
But it doesn't, I'm trying to show you where the numbers are coming from, not just.
yeah,
Gotcha.
no, that's,
Okay.
yeah, I got
Do you have to explain that in the report?
Yes,
you, yes.
when you're trying to explain where these came from. How many samples are left? One?
This is going to be 2 pentanol.
Okay. Okay.
You got it? Mm-hmm. All right. This one is the 1 propanol.
Okay. Now, okay, I'm going to ask you a series of questions.
Okay.
How did you go about putting this, like, what did you do? Okay,
Okay.
we gave you our sample.
Yeah, so what I did was I take these plates
Ooh, what's that?
and I washed it with methylene chloride first and scrubbed it off so it got nice and clean. And then I ran a blank sample with methylene chloride so we had nice clean, these are salt plates, these are
Salt?
sodium chloride
Okay.
plates. And then I take it off and then I take your sample, I pour it directly on here, close it up, make a sandwich out of it, and stick it on this thing, close the lid, and I start the IR up and it produces an IR spectrum.
Okay.
So then every time I just take it off, I clean it with methylene chloride, and then I go to the next person.
Okay.
So that's really all there is to it, and then you get an IR data set. So it just, all it does, makes sure, I need enough product to spread it out across those things, so that way the IR spectrum, when the IR ray fires at it, it's going to absorb a different wavelengths I'm going to be able to tell, so I'm going to be able to get different absorbances across the spectrum, based on the functional groups present in that compound. So,
Okay.
then you get an IR spectrum. So.
What things could go wrong with the IR spectrum that would not, like...
If you don't have enough of a product,
Okay.
I might not be able to distinguish some functional groups there. If you had a mixture of products, so if you had some starting material left over, so an example, if we started with alcohols and we converted them, so you shouldn't have any alcohol in this IR spectrum, so you shouldn't see an OH stretch in there. If you do see it, it could interfere and it could just help it make it look a little different then.
Okay.
So, and then I don't know what would happen after that.
Okay. Thank you.
Will you come here and hold this?
On the NMR spectrum, what could be some things that the shimmy could affect the reading, correct? I'm just trying to find some errors.
The errors don't need to be for the spectra itself, it has to be for the chemistry behind what is giving that spectra.
Okay. TW,
And you were pentanol or propanol?
2 pentanol.
Then you have propanol here. You have pentanol.
Is that mine? How you know? Okay, I see it. I'm giving you a hard time. I can't help it. Is that okay? Give you a hard time? Yeah, it is.